Hi, welcome back to another episode of Algebra and Words, the video series. Tonight we're going to continue our discussion on systems of two linear equations, specifically on the graph and check method. Okay, remember, if you would like to follow along with that in written form, you can follow along with that on page 59 in my book Algebra and Words, which you can find at Amazon.com, which the link is provided in the description box below. So anyway, let's get started and take a look at what we have. Now, what we're given here is two equations. This is the system of two linear equations. And what we need to find out is, we want to find out what the solution is, if there's a solution, and then if I remember, what type of system it is. So anyway, if you remember from the last video, we looked at two situations where we checked by testing test points. And that meant we were given either a point or we were given a graph from which we were able to decide the point, take the values of the point, substitute them into each of the original equations, and simplify down, and if the left side equals the right side for both equations, then that meant that the point that we tested is the solution. But in this problem, it's not that it's that much more complicated, but it does involve more steps, and so we will need some board room, you will need some extra room on your paper. Before we do it, I'm going to give a brief overview of the steps involved. Again, these are listed in written form in my book, Algebra and Words. So the first thing that we need to do is, we're given the equations, and what we need to do is create our own graphs for each of the lines. Alright? Now, let's pause there. There's two ways that you can make the lines for linear equations. I went over both methods in previous videos, more of the introductory of linear equations where we only had one at a time. But these are the two methods. You can either make a table of three points. I call it the 0, 0, 1 method, where you put 0 in for x, 0 in for y, 1 in for x, and you take those values, substitute them into one of the equations, and see what the other value is for its corresponding point. That's one way to graph. The other way to graph is, these are in standard form, is to take the form that it's in and convert it into slope-intercept form, and then that's a functional version, functional form of the equation. You can first plot the y-intercept, then use the slope, and then plot the line that way. So we get a little exposure. I'm going to show each of the two ways. Alright? Let's start with the top equation, and for this one I'm going to convert to slope-intercept form. Alright, so I'm just going to rewrite it here. And I forgot to put the y. So let's not forget the y there and the y here. So it's copied correctly. And now we want to isolate the term with y. So let's subtract 3x from both sides. That eliminates these and leaves negative 2y equals negative 3x plus 12. And now we want to get rid of everything except y, so let's divide all terms by coefficient negative 2. These cancel out, leaving y equals positive 3/2 x plus, actually it'll be minus, because we have 12 divided by negative 2, which will make negative 6. Alright? I'm just going to rewrite that equation so that we have a little more room to graph. So we got y equals 3/2 x minus 6. Alright, and I'm just going to pause this and erase some of that so we can put up a graph. If you needed to see that math, then just rewind the video, but I needed to make some space. So let's put a graph right here. And now let's plot this equation. Alright, make sure that when you do this, when you draw in the units, if you're sketching it like freehand, make sure that you do your best to make each unit about equal so that you can do the next step when you need to determine where the point of intersection lies, if it exists. So let's start with the y-intercept, which is -6, and let's go down 1, 2, 3, 4, 5, 6 units. Let's put a dot there. All right, and because this y-intercept is already so low, well, that doesn't matter, but let's start here, and we know that our slope is going to be 3/2. So we're going to go up 3 and to the right 2, and up 3 again and to the right 2. So those gave us pretty good points. Let's draw the line through those. Okay, that's good. So we now have one line graphed. But now let's find out how to graph this line, and let's use a different method to graph. Let's make a table of 3 points, the 0, 0, 1 method. So to do that, I'm going to first, with this equation, put 0 in for x. This cancels out. We get y equals -1. Let's put -1 in here. And now let's do it again, but this time put in 0 for y. X plus 0 equals -1. And this cancels out, so we get x equals -1. Let's put -1 now, in this case, in for x. And last, let's put 1 in for x. So we get 1 plus y equals -1. And subtract 1 from both sides, and we're going to get y equals -2. Put the -2 in for this point, and so what we just did is found 3 points that we're now going to plot. I'm just going to erase this to leave a little more room for the later steps. And what we're going to do next is, I'll use a different color, is we're going to plot these 3 points so that we get the other line. So 0, -1 would be here. And the next point would be -1, 0, that would be here. And the next point would be 1, -2, down 2. And now let's draw the line through those points and see what we get. Okay, so what we want to do now is, the best we can, is to look at the graph and try to determine what point the lines cross. Okay, so I'm just going to circle this region, and let's just do our best. So if this is 2 units here, and this is down 1, 2, 3 units here, then I'm going to, just with judgment, I'm going to say that this point is 2, -3. 2, 2, -3. And I wrote test by it because we don't know if that's the answer yet. It's just a test point. So now we're going to do like we did in the previous video, which is to test the point by taking these values and putting them into each of the original equations, simplified, and if the left side equals the right side for both equations once simplified, then that tells us that the solution is that the point is the solution to the system. If one or both of them turns out to be not the left side equals the right side, then that tells us that we were wrong, and that point that we're testing is wrong. So then we might want to go back and reevaluate what we did and what we thought the point was. So anyway, let's get started with that. Let's start with this equation, the top one. So I'm going to write 3, and in for x, 2, -2, and in for y, -3, equals 12. And let's simplify. 3 times 2 is 6, Negative 2 times